How do you even begin to move a 322-foot-tall moon rocket 4 miles to its launch pad? On the surface, it sounds kind of simple, but it's a question just packed with some of the most incredible engineering you can imagine. Today, we're going to dive into this journey before the journey.
And for a long time, this is pretty much how everyone thought about it, even some of the engineers. You see that old footage from Apollo or the space shuttle, this giant machine just crawling along, and it looks pretty straightforward, doesn't it? Just a big, slow, careful drive out to the pad.
Well, is it really that simple? As it turns out, not even close. The Artemis program has completely shattered that old simple truck ride idea.
And here's why that whole perception is just wrong. The Artemis II space launch system, the SLS rocket, well, it's a completely different beast. We are talking about the single heaviest and most structurally complex vehicle that has ever made this trip ever. I mean, just let that number sink in for a second. 11 million pounds. That's the weight of the rocket, the Orion spacecraft on top, and the whole mobile launcher it sits on, all bundled together. It's an almost unimaginable amount of mass to move with any kind of precision.
And that weight isn't spread out, it's stacked vertically, towering 322 feet into the sky. That is taller than the Statue of Liberty. So trying to keep something that tall and that heavy perfectly stable, that is an immense engineering challenge.
The journey itself is 4.2 miles, all the way from the famous Vehicle Assembly Building out to Launch Complex 39B. And at a top speed of only about 1 mile per hour, this is not a quick trip. We're talking about a slow, deliberate, and intensely monitored process that takes hours and hours to complete.
So you have to be asking, how in the world is this even possible? Well, it all starts with the first of 3 huge engineering pillars, the incredible machine that does all the lifting, the crawler transporter. Now, what might shock you is that these crawlers are the very same machines from way back in the Apollo era, but let me tell you, they are far from original. They've been massively upgraded. I mean, going from a design limit of 6 million pounds all the way up to being reinforced for 11 million. Everything from the hydraulics to the drive systems has been seriously beefed up for this new Artemis generation.
Let's just get into the nitty-gritty here. The crawler, CT2, it's got these 8 enormous tracks made up of 456 individual shoes. Now, this brilliant design distributes that 11 million pound load so perfectly that the pressure on the ground is only about 11 pounds per square inch. To put that in perspective, that's similar to heavy construction equipment. That is just staggering given the scale we're talking about.
Okay, so the crawler can handle the sheer weight. But how on earth do you keep what is essentially a 32-story building perfectly balanced on top of it while it's moving? Well, that brings us to our second pillar, precision load management. The secret sauce here is this really sophisticated software control system that uses something called PID algorithms. You can basically think of it as the crawler's brain. It's constantly taking in data from sensors all over the rocket and making these constant, tiny little adjustments to the hydraulic suspension to keep the whole thing perfectly level.
And the result is, well, it's just incredible. Even as the crawler is climbing the gentle slope up to the launch pad, this system keeps the entire 11 million pound stack leveled to within 1/10 of a degree. That is an absolutely mind-boggling level of precision. And this is so important because it's not just about, not tipping over. This active balancing makes sure that the immense stresses on the rocket's internal structure never even get close to dangerous levels. It's a critical safety system that protects the vehicle's integrity from the inside out. All right, so we've got the super strong vehicle and the high-tech balancing system. But what is it actually driving on? That brings us to our third pillar, the crawler way. And let me tell you, this is no ordinary gravel path. It's a piece of mission-critical infrastructure all on its own. The crawlerway is built in these specific layers. It's got a surface of compacted river rock that sits on top of a 4-foot-thick base of crushed stone. The entire path is engineered so that even with the full 11 million pound load pressing down on it, the ground settles less than 1 inch. And navigating this path, it requires incredible accuracy. You can't just eyeball it, right? The crawler uses a combination of laser guidance and advanced GPS to stay on course with a positional accuracy of just plus or minus 2 inches. And every single move is governed by strict rules, like a wind speed limit of 33 knots, just to ensure safety. So, when you step back and you look at all these pieces together, the crawler, the balancing act, the perfect path, you start to realize something profound.
This rollout, it is so much more than just a move from point A to point B.
It's the ultimate systems test. It's actually the one and only time before launch that the entire ground support architecture, we're talking all the electrical connections, the umbilical arms, the fueling systems, gets tested under the full flight-like mass and center of gravity of the actual vehicle.
And that brings us to this completely new way of looking at it. What we used to see as just simple logistics is actually deep systems integration. What looked like basic transportation is in fact full-scale verification. And that simple move, in reality, it's a highly complex choreography of mechanical, hydraulic, electrical, and software systems all working together in harmony.
So, in the end, the Artemis rollout is not just a drive, it's the physical embodiment of the incredibly complex architecture that connects the ground to the launch. It really is the final bridge from our world to the vacuum of space.
Which, it leaves us with one heck of a final thought, doesn't it? If this incredible system is what it takes just to get our moon rocket to its launch pad, what kind of monumental engineering are we going to need to invent to build the bridge to Mars?